In this section, we'll be dealing with ratios that contain more than two parts. How do you proceed when a ratio is composed of more than two parts? When a ratio has more than two parts, the easiest way to deal with it is to turn it into an algebraic equation. You would do so by multiplying all the parts of the ratio by the same variable, adding those parts together, and then setting them equal to the total number. Let's see what that means. For example, if a bag of marbles has red, green, and blue marbles in the ratio of 4 to 6 to 7, and there are a total of 51 marbles in the bag, how many red marbles are there? Well, we know that the ratio is 4 to 6 to 7. This is the traditional way we write ratios with a colon. So what we can do is we'll multiply all of those ratios by a variable. So instead of just a ratio of 4 to 6 to 7, now it becomes 4x to 6x to 7x. And then, instead of using the colon, we'll add them. So instead of 4x to 6x to 7x, this becomes 4x plus 6x plus 7x, and we set that to the total number of marbles, which in this case is 51. So to repeat, the two steps are multiply the ratios by a variable, and then add those ratios together. It helps if you have something to set that ratio to. In this case, the total number is 51. 4x plus 6x plus 7x is equal to 17x, so we have now 17x is equal to 51. When you divide both the left and the right side by 17, you get x is equal to 3. 17 times 3 is one of those products that you should memorize. 7 times 3 is always equal to 51, obviously, because it's the same two numbers. So now we're asked, how many red marbles are there? Well, if x is equal to 3, and we know that red was equal to 4x, because remember this is the ratio for red, and this is what we did, we multiplied that ratio by x. We now have that red is equal to 4x, which is equal to 12, because x is equal to 3. Let's see how this works out in some other questions. So the ratio of cars to bikes to trucks in a certain garage is 8 to 3 to 4. If there are a total of 90 cars, bikes, and trucks in this garage, how many trucks are there? First, we set up the ratio. Cars to bikes to trucks is 8 to 3 to 4. Then the next step is we multiply each of the ratios by x. So we get 8x, 3x, and 4x. We then add those ratios, 8x plus 3x plus 4x, and set them equal to the total number of things. In this case, there's a total of 90 cars, bikes, and trucks. 8x plus 3x plus 4x is equal to 15x, and 15x is equal to 90, because that's what we set the ratio equal to. You divide both the left and right side by 15, you get that x is equal to 6. Now remember, trucks is equal to 4x, because in the ratio, the 4 was under the t for trucks, and 4x is what we get when we multiply the ratio by x. So if t is equal to 4x, then t is equal to 4 times 6, because as we saw, x is equal to 6 once we did the math, and therefore there are a total of 24 trucks, since 4 times 6 is 24. Let's take a look at this question. So in the yearly budget of a certain pet store, the amount spent on rent, animals, and staff was in the ratio of 5 to 3 to 4, respectively. If the store spent a total of $45,000 on animals last year, how much did it spend on staff? Well, we would start with our ratio. Ratio of the money spent on rent, animals, to staff is in the ratio of 5 to 3 to 4. Then the next step is to multiply everything by a variable, in this case x. So we get that the rent was 5x, the animals were 3x, and the staff was 4x. Now we don't know the total amount of money spent on everything last year, but we do know that the total amount spent on the animals was $45,000, so that 3x is equal to 45,000. If we divide both sides by 3, we get that x is equal to $15,000. How does this help us? Well, we're asked how much did the store spend on staff. We know that the staff is 4x, and since x is 15,000, the amount spent on staff was 4 times 15,000, or 60,000. Therefore, a total of $60,000 was spent on staff last year. Take a look at this question. So an iced tea drink contains only iced tea powder and water in the ratio of 3 to 18. If Sam wants to make 168 ounces of the iced tea drink, how many ounces of iced tea powder does Sam need? This contains only 2 parts. However, we can use the same principle. The ratio here is 3 to 18. We can multiply both sides by x to get 3x and 18x for the amount of powder and the amount of water. We would add those two to get the total, in this case 168 ounces, because we know we're making a total of 168 ounces of the iced tea drink. 3x plus 18x is 21x, so we get 21x equals 168. You divide both sides by 21 and you get that x is equal to 8. So if x is equal to 8 and we're asking how many ounces of iced tea powder does Sam need, in other words we need to figure out what 3x is. If x is 8, we get 24 because 3 times 8 is 24, and so the answer is 24. You need 24 ounces of iced tea powder. Take a look at this question. A philosophy class at a certain university consists solely of freshmen, sophomores, and juniors in the ratio 5 to 8 to 4, respectively. If there are a total of 51 students in the class, how many more sophomores are there than juniors? So there's 3 parts to this ratio. We'll set it up the way we do when we have more than 2 parts. The ratio is 5 to 8 to 4. We multiply everything by x to get 5x, 8x, and 4x. We add that together and set that equal to the total number of students. So 5x plus 8x plus 4x equals 51. In this case, we get 17x equals 51. This should be this should be familiar to you. So if you divide both sides by 17, you get that x is equal to 3. Since we're asking how many more sophomores are there than juniors, we need to figure out what 8x is, because that's the total number of sophomores, and we need to figure out what 4x is, because that's the total number of juniors. If x is equal to 3, 8x is going to be 24, 4x is going to be 12. If you want to figure out how many more sophomores there are than juniors, you subtract and you get 24 minus 12 equals 12, so that there are 12 more sophomores than juniors.